So now we will look into how to determine first and second derivatives of parametric equations. So when you have x in terms of t, y in terms of t, and y is fx, then it's possible to determine f prime and f double prime x by applying chain rule. So for example, f prime x is dy dx. So dy dx can be obtained by using the chain dy dt multiplied by dt dx. Because we can determine dy dt from here. Y, when you differentiate y is dy dt. When you differentiate x is dx dt, and when you can flip it to divide it. So in other words, the simpler way to write out the formula is simply y prime over x prime. So dy dx is, for parametric equations, is y prime over x prime. Whereas for the second derivative, d square y dx square, we will actually use, these are all mathematical terminologies, yeah? So simply means you differentiate the y again, and when you differentiate the y again, it's as if it can be shortened down to this formula: differentiate y, divide by differentiation of x. Okay, so this can be further wrote in an easier way using the Leibniz notation y prime x prime, and you can summarize it in this term. So this is the formula for you to get the second derivative, which is y double prime multiplied by x prime minus x double prime multiplied by y prime over x, differentiation of x cubed. Yeah, you can combine square and x prime, it will become x prime cubed. So as you can see, you can actually summarize your second derivative formula in terms of using the Leibniz notation: y double prime times x prime minus x double prime times y prime over x prime cubed. So for example, find f prime and f double prime when x is such and y is given in terms of t as well. So your first task will be f prime based on the previous formula in the previous slide. So f prime is y prime over x prime. So identify x prime and y prime first. So you have got y prime will be negative 60 and x prime is actually 4. So that's the easier way you see to derive your first derivative of a parametric equation. And you can simplify it if you want to. And the second derivative, based on the formula up here, you see y double prime, if you differentiate y double prime again, you will get negative 6 y double prime. X prime is 4. So y double prime times x prime minus x double prime. When you differentiate 4, first derivative gives you 4, second derivative will definitely give you a 0. So x double prime is 0 here, multiplied by y prime is definitely negative 60. So this part will be 0. So you can reduce, and then your answer to over 4 cubed. 4 is obtained from the first derivative just now. Substitute 4, x prime is 4 cubed. And your answer can be reduced further to negative 3 over 8. So we will look into the next example. If you're given a locus which is represented by parametric equations x and y, and you need to solve these three questions. First, find the point on the locus corresponding to a parameter value. Theta is pi over 2. So this is as simple as substituting theta as pi over 2 to determine the value of x and y. And then when you need to find the gradient is simply f prime x or dy dx. So you need to apply the dy dx formula. Okay. And the third one is actually find concavity. Concavity here, it relates the second derivative. So d square y dx square. So we will apply what we learned just now. Okay. So you substitute x theta as pi over 2. into x and also y in order to get a point. So thus the point on the locus is actually 3, 9. Okay. For part B, we will actually we need to identify the dy dx. So dy dx is simply y prime over x prime. So from the original x and y equations, x prime is -5 sine theta and y prime is 5 cos theta. So f prime is y prime over x prime, and you can further reduce this to 1 over tangent, which is negative cotangent theta. So when you substitute pi over 2, you will actually reduce your answer to 0. So therefore, when the dy dx is actually 0, therefore the tangent is actually horizontal. For the part C, we need to determine second derivative. So second derivative for parametric equation involves x prime, y prime, x double prime, and y double prime. So it will be useful if you identify everything x prime, y prime, x double prime, and y double prime. So they can substitute it into the formula straight away. So we sub it into the formula. Y prime, x prime, so sorry, y double prime, x prime minus, this will be x double prime, y prime, okay, over x prime cube. So substitute it, and you will reduce your answer to this part. Okay, once you reduce your answer to this part, you can actually simplify it further, and you will reduce your answer to, and here, when your theta is actually pi over 2, your f double prime max is -1 over 5. Therefore, your f double prime max is less than 0. Less than 0 normally represents a maximum point. So your curve is actually concave downwards.